learn some dot product. So, okay, so the way the dot product works is you're going to take a vector A and you're going to dot product it with a vector B. You guys want to tell me how this works? What are you going to get? How about that? Okay, you get a scalar. Okay, so this is going to be a number in R. And if I had A was like coordinates, A1, A2, A3, and B was B1, B2, B3. How would you do this?
A1 times B1 plus A2 times B2 plus A3 times B3.
Okay, you said it right. I wrote it wrong. Okay, so we take the first coordinates, multiply them together, add that to the second coordinates, multiplied together, add that to the third coordinates, multiplied together. Okay, 1, is this as I claimed a number?
Should be.
Why? Like, convince me it's a number.
Each entry is a number.
Inside the vector.
Product of numbers are numbers.
Yeah,
Sum of
so
numbers
inside
are
the
numbers.
vector, the coordinates are numbers, right? And then
Product of numbers are a number. And then
Okay.
sum of numbers is a number.
perfect. Yeah, these operations are all in scalar land, right? Okay, so this is in fact a number. Why is this number good for anything at all?
Oh, because of the unit vector. If we have like 1 over an amount, can we apply that?
Kinda, yeah. This would give us an easier way to get unit vectors, maybe.
Okay.
Maybe not even, let me see. What if I took A, so A1, blah, frame, A1, A2, A3. What happens if I dot this with itself?
Just equals 2a vector.
It's not a vector, right?
It's
It's got to be a number. But what is the number?
A1 squared
Good. A1 squared
plus A plus A2
plus A2 squared plus A3 squared.
which is the square of its length.
Yeah, that's the length, but squared, right? Okay, so this is the magnitude of A squared. Okay, so the first thing that's worth remembering out of this is this guy. You want to get the length squared, you can just dot product the vector with itself. Right? Cool.
Is
Yeah.
is normal format be the magnitude squared, or would it be is there a difference between a squared and magnitude?
Ah, that's a good question. So
God bless.
you're asking about this symbol?
Yeah.
Does this symbol make sense to us?
Well, not
Convince me one
necessarily
way or the other.
like
Is it the
a
same thing?
vector squared, but like a squared within the magnitude.
Yeah,
So would that be?
like this.
Oh, okay. So it
So
would have to be a vector.
There's
yeah.
some mixing operation problems, right?
We're just
And I-
missing a vector on the A over there.
Oh. Thank you.
Okay, that's why. Then yeah.
Thanks. So, right, the only thing I know how to take magnitude of is going to be a vector. I don't know how to take magnitudes of a number, right? Because a magnitude of a number is an absolute value, not a magnitude. Right, so I have kind of an extra set of brackets. So if I try to write something like this, you guys tell me why this doesn't make sense?
We can't multiply vectors.
Yeah, I don't know how to multiply a vector by itself, right? I know how to dot product a vector, but that does not mean multiplication, so I do not write these dot products as powers. Let's go all that. So this is a no-no. Cool? I want to be totally clear, right? this thing is it's some kind of product. And the reason we write it like multiplication is it acts a little bit like multiplication, but it is not multiplication. Okay? If it were multiplication, I probably would want to get a vector back out, and what I get is a number. What does that number tell you? You guys know something about that? Okay, forget it for right now. For right now, let's go with the idea. It's a good way to get a hold of the length, right?
That's what I was going to say. The length, right? That's all it is. Or it's
There's a little something more there. When I do two different vectors, there's a nice thing that happens, but let's forget it for right now. Let me write down what I meant by it acts a little bit like multiplication. Okay, so properties. Okay, so what I mean by it acts a little bit like multiplication is if I take A and dot with B plus C, all vectors. What would you expect to have happen here?
A dot B plus A dot C.
Seems like I should probably get A dotted with B plus A dotted with C. Right, if there was justice in the world, and I wrote this like multiplication, it should darn well act like it, right? Does this work? How would you see this? Like, if you wanted to convince yourself this was true, what would you do?
build a model or like
Yeah, you could write down, right, 3 sets of vectors, right, or 3 sets of numbers like this. And then you could add them together. I know how to do that, right? And then I'd multiply. You guys see that? Would it work? Should we try it? You guys want to spend a second to try it?
Yeah. I'm just trying not to dive into proofing notation. Where you have a general vector, 3 general vectors.
No, that's exactly
You do
what
the
I want.
operations on the 3 general vectors.
Yeah, so I want 3 general vectors. So my 3 general vectors for this are going to be A1, A2, A3, right, as a vector. And then I want to dot with, okay, so I'm going to think about B as B1, B2, B3, right? And think about C as C1, C2, C3. What are you going to get when you add those together? B1 plus C1, B2 plus C2, B3 plus C3, right? Okay, then we're gonna what?
Then
Do the dot
distribute
product
A
thing,
to
right?
individual things.
Okay, so if I do the dot product thing, I'm gonna get A1 times
B1 plus C1.
B1 plus C1 plus A2 times,
B2 plus C2.
perfect, B2 plus C2 plus,
Same with 3.
A3 times B2 plus C3.
good. Okay, then what? What does your little heart want to do with these numbers?
Distribute and rearrange.
Yeah, it probably seems like distribute and rearrange, right? So if you distribute, you'll get A1, B1. What's the first term you're going to get out of this guy? And the first term out of that guy?
A3 times B3.
Right. Okay. Then I got the first terms out of each one, right? What are the second terms?
A1 times C1. A2 times C2. And A3 times C3.
Cool. Alright. So what are these guys?
A
Be
dot B.
the vector.
Yeah, that's A dotted with B. And these guys?
A dotted with C.
Cool. Got it? So why does it act a little bit like multiplication? What was the key here? What did I do?
Distribute.
Yeah, I was trying to say that this dot product distributes, right? And why does the dot product distribute? Because regular scalar multiplication distributes and addition doesn't give anything about the order there. You guys see that? Cool. Alright, so let's see. What other interesting properties does the dot product have? What happens if you take 0 and dot product it with something?
Gonna get 0.
0? Why?
It's like 0, 1, 0, 2, 0, 3 times A1, A2, and A3.
Good. Yeah.
Yeah, like the vector.
Right, there's this 0 vector, right, is made of 3 zeros in the coordinates. Then you're going to what? You're going to multiply those zeros by the coordinates of this one. That's going to zero everything out, right? And then add it all together. Does that thing need a vector hat?
Oh,
Why not?
just get a number.
Yeah, it's a scalar, right? It should be a scalar. Because the dot product should output a scalar. Let's see, what else do we need? Oh, we need multiplication properties. So what if I took A and dotted it with some scalar K times B?
Be the same thing as K, A vector, dot B vector.
Okay.
Should we throw some parentheses on it?
Yeah, so I probably should throw some parentheses in here too, right? So I mean A vector dotted with the result of the scalar multiplication, K times the B vector. And I'm saying, okay, that's the same thing as this result of the scalar multiplication, K times A, dotted with B. And what else should that be the same as?
K times the quantity of A vector times B vector.
Okay. With one small caveat. How would you read that?
Dot.
Dot, right? So K times the quantity A dot B, right? To drive home that it's not. I know.
Technically, it's the second.
It's the second bit.
It's the first vector day. So once you've had some practice with vectors, I don't really care if you call it times. But I'd like you to remember that that's not quite multiplication, right?
Is there something about AB cosine theta?
Oh, dude, there totally is something about AB times cosine theta. Okay, let me turn this off and then we'll do that.